Okay, this video is about the partial geometric sums. And here is the formula that we are going to use, where we know that our first term is u sub 1. We need that in order for this to work. We also need an r for this to work, which is our common ratio. And we need a k. And that is going to be, if there are 8 bounces, then it's going to be 8. If there are 15 days, then it's going to be 15. If it's 4 months, then it's going to be 4. So it's going to be however many things or actions there happen to be. Easier to see that when you do a problem. So let's drop the ball and see what happens here. A ball is dropped from a height of 9 feet. It hits the ground and bounces to a height of 6 feet. On each bounce, it rebounds to 2/3 of its height of the previous bounce. How far has the ball traveled, both up and down, when it hits the ground for the 7th time? Okay, so for our u sub 1, we need the distance of the first bounce. For our r, we need to know how far it rebounds each time. For k, we need to know how many bounces before it hits the ground the 7th time. Now, this is the formula. I'm going to leave it there so that you can look at it and make sure. You'll notice that right here at u sub 1, we still have our u sub 1, but we have our initial drop of 9 feet that we have to add in here right at the end. So don't forget to add the 9 feet at the end. We're just going to ignore it until then because we have to do all of this according to the order of operations before we can add that 9. Let's look at our bounces. So it's dropped from an initial height of 9 feet, which we're ignoring. Then our first bounce, it says, it hits the ground, bounces to a height of 6, and then back down. That means this whole distance from up and down is going to be 12 feet. That is our u sub 1. So we'll put that right here in u sub 1. Now for the rest, we need to figure out what our common ratio is, and that's easy because it tells us it rebounds 2/3 of its height each time. Then we need to figure out k. Well, how many bounces are there? We need to know how many bounces there are by the time it hits the ground 7 times. So if you count them up, you can see that there is 1, 2, 3, 4, 5, 6 full bounces when it hits the ground the 7th time. So we have to put everything in our equation. We now know that k equals 6 full bounces. We have our 9 for the end. We have our u sub 1 for 12. Our common ratio is 2/3. And since our k is 6 up here, it's also 6 up here. Moving right along. Now, this is what it looks like when we put it all together. And what I want you to see here is that we have our first drop plus the sum of all 6 bounces. That's what this part is, plus our original 9 feet drop. Now, all that's left is to do the math. So this, I know it looks ugly, but when we do fractions, we want to go step by step so we don't make any careless errors. The first thing we have to do is our exponents. Because of the order of operations, we're going to do this all according to the laws, the math rules. So 2 over 3 means 2 to the 6th over 3 to the 6th, which is 64 over 729. And then we're going to come over here, and we can't subtract these without having common denominators. So if you have a common denominator, it's going to be 729 over 729. And I'll change this to 3 over 3 so we can easily subtract those. When we do that, we end up with 665 over 729 divided by 1/3. Well, I'm just going to divide these. When you divide, you multiply by the reciprocal. So I'm going to flip it over here and make it multiplication. Then I'm going to cancel wherever I can. And I know I can cancel 3 and 729 because of those rules of divisibility. And then I end up with 243 in the bottom, in the denominator. I can cancel again between 12 and 243, and I end up with 81 on the bottom. And you could probably use your calculator and change it right here, but I always cancel as far as I can because it makes things simpler. But when you get to this point, it is okay to change it into a decimal because we're just going to multiply and then add. Now, if we changed all of this into a decimal, our answer is going to be quite different from this because we've rounded all the way down. So just wait until the very end, change it to a decimal, multiply by 4, add 9, and you should get 41.84 feet. And also, don't forget, this is a word problem, and so I'm being a little bit lenient, but don't forget the rule. It starts in a fraction, it should end in a fraction. Now let's look at the next one. Another ball is dropped from a height of 10 feet, and on each bounce it rises 45% of its previous height. When it hits the ground for the 10th time, how far has it traveled? Well, again, our u sub 1 is the distance of the first bounce, but let's think about this. It drops 10 feet, then it rises up 45%, and then drops back down again. So that's going to be 45% of 10 feet, and we're going to need it twice, both the up and the down, to get the total distance. So that's going to be a total of 9 feet. Now, our R, our common ratio, is going to be the 45% that it changes each time. And then we'll have, if it's on the 10th time it hits the ground, there will be 9 full bounces. If you remember the last time, on the 7th time, there were 6 full bounces. So that means our K is going to equal 9. We're going to do the same thing. We have our first initial bounce right here, or our drop, and we have all of the sum of all of the 9 bounces right here. We put in our R, which is 0.45 to the 9th power. That's going to be an interesting number. And then here we have simple subtraction. Now, all that's left, once you get it in this form, all that's left is to just do the math. So it starts out here, and 0.45 to the 9th power, you're going to have to round a little bit here. It's going to be 0.00076 if you round correctly. Then go ahead and do the subtraction, and you get this. Then you do the division, and you end up with 1.8168 times 9 plus 10, and believe it or not, that comes down to a very convenient answer of 26.35 feet. Now, let's try one completely different than the bouncing ball. And let's just say that you are going to be paid a salary of a penny on the first day of March, and you'll get 2 cents on the second day, and your salary will continue to double each day. How much will you earn in the month of March? So we're going to add all those up and get the sum of that. So here's what we need to know. We need to know our first term. We have nothing to add at the end, thank goodness, but we need our first term, which is a penny. That's where we're starting, 1 cent. Then we need to know our common ratio. Well, it's going to double each day, so it's going to be times 2. And then what is our K? Well, how many days are there in March? There are 31, so K is 31. So when you get it all plugged in, this is what it looks like. And isn't this going to be an interesting number, 2 to the 31st power? Now, we just do the math. So when we find 2 to the 31st power, you're going to end up with, let's see, what is this? 2,147,483,648. And we're just going to do the straight subtraction. And when we do 1 minus that, we're going to end up with a number very similar. This is the only thing that changes right there. But it does end up negative. And also on the bottom, 1 minus 2 gives us a negative 1, which is very convenient because when we divide, it just makes this positive. We multiply by 0.01, and believe it or not, we end up with 21,474,836.47. So the next time somebody wants to pay you for a month, tell them you start with a penny and double it every day.